Okay, this is major quiz number 3 review. Let's take a look at it. And I mean, we've done all of this already, but let's just take a look at it. We need to find A and B using the linear regression formula. If you remember how we did this, the first category in this table, hang on, my pen's not working. There it is. The first category in this table, we put all of this in L1 and we put all of this in L2. So let's do that on our calculator. Put that data into L1 stat, number 1 edit. I'm gonna clear L1 and L2. And in L1, I'm putting 34, 21, 25, 34, 21, and 24. In L2, I'm putting 290, 263, 312, 301, 319, 236. If somebody's following along, try to keep me honest here to make sure I get these right. Okay, so I typed in all my data into L1 and L2. R is 0.182. Can you tell me something about this R? Anybody remember anything about having an R that's 0.1? Regression should not be done. Remember I said if anything less than I think it's 0.6. I think I said 0.65, around 0.6. If R is less than 0.65, then regression should not be done. And I don't think we have to fill these out. So if I just click on regression does not have to be done, or I don't think it's going to let me do this because I'm reviewing, or maybe it is. I don't know how I'm gonna, let's see. Where's the answer? Oh, maybe they don't want, maybe I don't, there's no submit button or something for me. I think because I'm reviewing it, I don't get anything. But regression does not have to be done here because R is less than 0.65. But if we do regression, let's show you what A and B look like. So I'm going to make this bigger. I've typed in L1 and L2 to find A and B. We go to stat, calculate number 8. Stat, once again, stat, arrow over to calculate, and then go to number 8. And I'm using an old calculator, so let me see if I can find my newer calculator. Here it is. Well, I'll use my newer one for the next problem. But there's my A. From on here, there's my A. And there's my B. And there's my R, 0.18. Remember, that's what they got. That's a very low R. Remember, R, a perfect 1 means that's positive and going up. The line's positive and going up. A perfect R equals -1. The line is perfectly straight and going down. It matches the data perfectly. So an R of 0.18 is really bad, and regression should not be done. Okay. Let's take a look at the next question. And if you look here, R is 0.9. It's more than 0.65, even though it's a negative. Negative just means the data is going down. So it's 0.9. So yes, regression should be done. And we're going to type this data in. Let's see if we get the correct answer here. This is all L1 and this is all L2. So I'm going to do that. Stat number 1. L1 is, oh, why do they have to make it so hard with these 2 decimal numbers? 78.52, 81.72, 87.10, 86.07. $14.58, 23.55, 23.56. So hopefully I typed everything in correctly. Hopefully I typed in everything correctly. So now I'm going to go to stat, arrow over to calculate, and go down to number 8. And X list should be L1, Y list should be L2, frequency list should be blank, arrow, arrow, arrow. You can hit enter, enter, enter. And there's my A and B. And remember, if you don't have R on your calculator like this one, I didn't do R, you have to go to second catalog and go all the way down to turn diagnostic on. This is in that video that I did when we did this. So if you don't see R, you have to turn diagnostic on. It's going to say done, done, it's done. So now when I go to stat calculate number 8, not only will I see A and B, but I will see R also. So there's my A, there's my B, and we just type it in. So, and it says round the coefficients to at least 3 decimal places. So A, I get 111.8899, which rounds to 111.890. 3 decimal places. You add 1 to this, and from 89 it goes to 90. B, I get negative 1.1291, which 3 decimal places is that. And then they want you to put it into the equation, and that's just, there's the equation is A 111.890 plus B. Well, it says plus B, but since it's a negative number, you have to put minus 1.129x. So that's what the equation looks like. And then they told you, we'll get to it, I think later on, predict what it would be if x equals 17. Then you plug 17 in here and do the math. If that was one, I think that'll come up later on. All right, number 3. Remember, there's only 3 possibilities we can write in. Oh, there's a question. Oh, they gave us a value for X. I didn't see it. If we do it again, we'll come up with it. We'll do that. Remember, there's only 3 possibilities that you write down for HO or and H1. HO always is equal, so the average equals, the average equals, the average equals. Then you can write the average does not equal, the average is less than, or the average is greater than. These are the only 3 answers you can give in a type of problem like this. The average cost of high school games is 88, so the average is 88. It doesn't say less than, greater than, or anything else. So the only option is the average is not 88, what the scientists could predict. State the null and alternative. Well, the null is the average game is 88. So the null, the alternative hypothesis is the average is not 88 because it doesn't say less than or greater than. Number 4. The average of the first year student is at least 27. Well, we know the first one has to be equals to the number, equals 27. So at least, and when you go through the homework, remember those are 2 I showed you on the homework video for 10.2. At least was less than, and then if we had at most, that would be greater than for the H1, for the alternative hypothesis. So make sure if you haven't watched those videos or didn't take notes during those videos that you do that. Finally, margin of error. So this is a confidence interval. 0.538 and 0.806. We want to find the average. First, we want to find the average here. We want to find what this average is. And if we add the low and the high up, we can find and divide by 2, we can find the average. 0.538 plus 0.806 divided by 2. 0.538 plus 0.806. Add those up and then divide by 2, and I get 0.672. 0.672. Now, we want to find the margin of error. The margin of error is how far it is from here to here and how far it is from here to here. It should be the same distance. So if we do from here to here, 0.672 minus 0.538 minus 0.538, and we get a margin of error of 0.134. And you can subtract these 2 also. 0.806 minus 0.672. 0.806 minus 0.672. And you get, well, I get 1.33. So I must have typed something in wrong or something. Oh, yes, I did. It should be a 4. I typed in the number wrong. So that should be 134. It should be the same margin error on both sides. So that is that should be 134 because I typed it in wrong. And so do you see the margin of error is 0.13 or 0.134 on this side and 0.134 on this side between these two. But in order to do that, you have to find the midpoint first, the average of the two, add them up and divide by 2, and that will tell you what the average is. Find Z alpha over 2 for 90%. Now remember, 90%, that means Z alpha over 2 is there, both ends are shaded in, and we need to find the Z value, and we're only going to write down the positive one. It's the same Z value on both sides, except one's positive, one's negative. For 90%, we have to do 5% here and 5% here, right? That's 90% confident, 5% on each side. So on our calculator, we do a second vars number 3 inverse norm, and we're going to do it for 5%. So let me show you on my calculator. Second vars number 3 inverse norm, and 90% is 0.05, right, on both sides, and it should give me a negative Z value, negative 1.64.
You're stuck again. I'm back. My other computer. Okay, so I'm back. Sorry, my computer reset itself. So I'm just going to go ahead and do the one we were doing, 90%. And that means we had 5% shaded on this side and 5% shaded on this side. So you have to find the Z value. When you find this one, it's going to be negative. And when I did it on my calculator, I got, once again, I typed in second second vars, number 3. The inverse norm. And I typed in 5%, 0.05. And I get a negative 1.644. Wait, they want 2 decimal places. So negative 1.64. And over here it'd be positive 1.64. So they just want the positive version. And there's our answer. I'm almost certain that's all they want. You can try it out on the homework, but it should just be the positive version. They tell you what it is for both sides. Yeah. Number 7. Find the 90% confidence interval. Oh, why did I change the question? There we go. A random sample of 46, n equals 46. The average is 3984, and population standard deviation is 650. So we're going to type this in on our calculator. Anybody remember how to get it? Oh, there we go. I found it. So to do the confidence interval on our calculator, we have to type in stat arrow over twice to tests, and then down to number 7. Number 7, Z interval. And then we're going to go arrow over to stats. I'll show you this on the calculator here in a second. Hit enter. And we have to type in our standard deviation, which is 650. Our average was 3984, and our N was 46. Our confidence, it said, a random sample for attending a daycare center provide a yearly tuition average. Oh, 9. I was looking for the percent confident. It's down here, 90%. And you do have to type in that confidence level also. Now that's what I was missing. 90%, 0.90. Okay, so let me show you that on my calculator now. I don't know. Can we make it just, there we go. So to type this in our calculator, we go to stat, arrow over twice to tests, all the way down to number 7. This is to find your confidence interval. Hit enter. And you'll probably be over here in data, but we're going to go, oh, actually, we just got to keep it in data. I've said stats, but we keep it in data. And there's our standard deviation we type in. There's our average we type in, or mean. And there's our N, 90% confident, 0.90, and then we hit calculate. And right up here, this is our answer. There's our confidence interval. Okay. So the confidence interval on the left side, I get 3826.4, and on the right side, I get 4141.6. There's our confidence interval, 90%. And we go to stat, arrow over twice to tests, down to number 7, Z interval. And then we leave it in data. Just leave it goes data or stats. We leave it in the data. We only go to stats if we're going to type in our data, but just leave it in the data and then type in the standard deviation, the average, and the confidence level. And then you should get this. Now I did it for oh, there it is, 90%. So it changes all the time. And the last question, sample. It says the researcher needs a sample. So anytime we need a sample, remember N was that formula, the Z alpha over 2 over the standard deviation and the error, and then we squared it, if I'm not mistaken. Yeah. So how many days a researcher select when there's an error within 4 degrees? That's the error. So the error is 4 degrees. The error, I need to change to 4. 90% confident. So we have to find that Z alpha over 2 for 90% confident. And I think we already did that. Didn't we get 1.64? But let me just remember those. That's one of those that you have to write down. Stat calculate. %90 is 0.05. Yeah, the Z alpha was 1.64 for 90% on my calculator. And then the standard deviation. Now be careful, because this one asks, we need the standard deviation. This one, where is it? Where is it? I covered it up somewhere. The variance, see, it says the variance is 32. The variance is 32, but we want standard deviation. Remember, standard deviation equals the square root of the variance. So the standard deviation equals the square root of 32 in this case. Square root of 32. So we're going to do the whole inside, 1.64 times the square root of 32. I hit enter, then I divide it by 4, and then I raise it to the second power. And we get a very small number. I get a number 5.37. But remember, when you get a small, any bit of a fraction, you have to take it up to the next whole number. So the sample needs to be at least 6.
if I typed in everything correct, 1.64 times the square root of 32. Yeah, divided by 4. Everything's right. And then I square it. And we get 5.37, which rounds up to 6. So we need a sample of at least 6 in this problem. And that is what the quiz looks like.